Welcome back. This is again continuation of the probability of permutations and combinations. I highly recommend looking at the previous video first just to familiarize what is a permutation, what is a combination, how can you differentiate between both of them. So now taking one step further, using those permutations and combinations, we will be working probabilities. Again, quick recap. Permutation is where your arrangement matters, just like in this case. As you can see, permutations is where the order matters. You can see everything is neatly arranged. So if you have tomatoes in the first, that's a different arrangement. Tomatoes in the bottom, that's a different arrangement, as you can see here. And I have potatoes. So as I'm trying to show you an example of what a permutation looks like, where the arrangement definitely makes a difference. Now, a combination is like a salad. You throw everything into a salad bowl, doesn't matter what you throw, right? So that's how a combination is. For a probability of permutation, you will have probabilities number of ways of the event occurring over the total number of permutations. Same is the case with combination. Combination is number of ways of the event occurring by the total number of combinations. Again, we'll take it problem wise so you can see how to think when you solve the problem. All right, let's go ahead and take a look at the first problem here. All right, a youth basketball team is made up of 7 boys and 3 girls. If the player can play on the court at a time, what is the probability that all the players on the court are boys? If you, I highly recommend taking a look at the previous video. We have done a problem like this where the coach picks the players to give them specific positions. So when you assign a position, it's a permutation. When you don't assign any position and you randomly pick a group or you choose a group, it's a combination. So let's take a look at this problem and see if is the coach assigning any positions or is the coach just randomly picking. So let's go back and take a look. Youth basketball team is made up of 7 boys and 3 girls. 5 players can play on the court at a time. So no positions, just 5 of them can play on the court. What is the probability that all the players on the court are boys? So starting with, remember when the probability, when you look for probability, let me expand this here. Am I expanding it? Yeah, well, not really. There you go, I'm expanding it. So when you're looking for probability, so here, when I say probability, I know it's going to be a fraction, right? So the denominator is always the total number of permutations or combinations. So it's the sample space. So when I say sample space, how many ways can you pick 5 players from 7 boys and 3 girls? So I remember I'm choosing. It's not permutation, it's a combination because order does not matter. I'm just going to choose them. There's no positions. So start with the denominator. How many ways can I choose? I have 10, 7 boys, 3 girls. So from 10, I am choosing 5. So in this 5, I can have boys and girls, right? So that's how you start. How many ways can you choose 5? That's your step 1. And remember, it's a probability. Probability of what? They're asking you, what's the probability of only picking boys? That means I do not want girls in my team. How can I pick 5 boys from 7 boys? 7C5. Fair enough? 7C5. And that's exactly what they gave you the hint here. The first one is you're picking 5 boys from 7 boys. That's your numerator, number of ways of picking boys. The denominator is always how many ways can you pick 5 from all of them. So you have 10 and you're picking 5. Again, you're going to go ahead, plug this in your class calc. Let me go ahead and show that to you. So this is your class calc. Let me delete it. As you can see, I'm going to go ahead, NCR, right, divided by another NCR. Now I'm going to go ahead and plug in. What was the first one? 7 and 5. What's the second one? I mean the denominator? 10 and 5. And if you want it in fraction, you simply go to decimal and then click fraction. So your answer is 1 over 12. So your answer is 1 over 12. Fair enough? So again, you simply go to your class calc, NCR over NCR, plug in what your N is, plug in what your R is, plug in what your N is, plug in what your R is, change from decimal to fraction depending on how they ask you in the homework. All right, let's go ahead and take a look at the next one. All right, look at the next one. Let's read the problem first. And again, remember, this is given to you. So if it's a P, they give you a P. If it's a C, they give you a C. That's the hint, right? But if they did not give you something like this, how will you go ahead and take a look? So let's read the problem here. A credit card company requires that its customers choose four different digits from, let me minimize this. Da, 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 da. All right, let me move this up. There you go. Four different digits from 10 digits total for their PIN, personal identification number. What is the probability that the customer chose a PIN number where the first digit is 3? So let's forget about the probability. Let's ask ourselves a question. Is this permutation or is this a combination? Let's say you are choosing a PIN. 1, 2, 3, 4 is your PIN. How many digits? 4 digits, right? 1, 2, 3, 4 is your PIN. Is this PIN same as 2, 3, 1, 4? The numbers are same, but is the PIN the same? No, it's not. What does that mean? The order makes a difference. The arrangement makes a difference. So if 1 comes first, that's a whole different PIN. If 2 comes first, that's a whole different PIN. See that? So this is a permutation. It's not a combination. And again, they give you a hint by putting a P in there. All right. Again, they're asking for the probability. Remember, how do I start? I always start with number of ways of choosing 4. So I have 10 digits. From 10, I am choosing 4. This is a permutation, right? From 10, I'm choosing 4. Fair enough? All right. Let me see something happen here. Okay. From 10, I'm choosing 4. That's my denominator. How many ways can I choose? 4 from 10. Now, what is the probability they're asking me? They're asking me what's the probability that the first digit has to be 3. So it's a 4-digit PIN. 1, 2, 3, 4. And the first digit has to be 3. So if from the 4 digits, if the first one has to be 3, how many can I choose? You can only choose 3. Do you see that? Because the first one is chosen. Can you see this? The first one is chosen for you. You only have to choose from the 3. But keep in mind, the first one has to be 3. So from your, let me pick a different color. From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The number 3 is taken already because the number 3 has to be your first digit. You have to choose 3. How many digits are remaining? You cannot choose 3 again. So 3 has to be your first number, right? Again, you only have 9 to choose from. So from the remaining 9, you have to choose 3. So which is 9C3. Fair enough? There you go. And that's exactly what you put in. So you first start with probability denominator. Number of ways of choosing 4 from 10 is 10p4. And they're asking you the first one has to be a 3. So boom, the first digit is taken. You only have to choose from the 3. But how many digits are left? 9 are left because 3 is taken already. So it's 9C3. Again, you will go ahead, plug this in your class calc. Let me delete this one. Let me bring up my class calc right here. I'm going to stats, NPR, You see how I'm moving all the way to the right and then clicking divided by, stats, NPR again. Now I'm going to go ahead and plug in. The bottom one is 10 and 4. And I'm going to the top one. The top one is 9 and 3. As you can see, I have a decimal. I'm simply going to click on the decimal and change it to a fraction. 1 over 10 is your final answer. So I'm going to go ahead and plug in here. 1, let me erase this. So your final answer is 1 over 10. All right? Okay. Let me take away my class calc. All right, let's take a look at these problems here. Where is this? All right. A child randomly selects 4 blocks from a box containing 3 red blocks and 2 green blocks. Pause and see if it's a combination or permutation. The child is just choosing red blocks and the child is choosing 4 blocks from 3 red and 5 blue. Does it make a difference which red one comes up first? I don't think so. Again, take a look at your options. If you see a C, it's a combination. So that's telling you the order does not matter. Okay, so the child has to pick 4 from what? From 3 red, 5 blue, and 2 green. So there's a whole big bin here, and the child has 10 blocks altogether, and the child has to pick 4 from the 10. So that's going to be your denominator. Remember when you're trying to find the probability? So they're asking you, what is the probability that the child selects all 3 red plus 1 other block? So that is very confusing. So let's take a look here. Step 1, probability is how many ways can you pick 4? So you will not look at the condition. You'll only see the child is picking 4 from 10. So the child is picking 4 from 10, and you know it's a combination, 10C4. Now, remember the child has to pick 3 red. How can the child pick 3 red? How many reds do you have? 3, 3 red blocks. So picking 3 from 3 is the child has to pick 3 red from 3 red. There you go. And is multiplication. And 1 from the remaining. So if I take away the 3 because the child already picked 3 from the 3 red blocks, how many of them are remaining? 5 and 2. So 7. 7. From the 7, the child only has to pick 1. There you go. 7C1. So you can see that step 1 is to see how many ways, it doesn't matter blue, green, red, black, whatever color. You're only looking at how many ways can a child pick 4 from 10. It's a combination, 10C4. Now go further and see what is the condition. The condition says he has to pick 3 red. There are only 3 red. And from the 3, the child has to pick 3. And the other 1 block that the child has to pick can be from the rest. But how many of them are remaining? 7, because I have 5 blue and 2 green. Fair enough? There you go. Again, plug this into your class calc and see what you get depending. You know what? Let me do that for you. Let me close this, cancel this, open my class calc. Again, stats, it's a C, so NCR. As you can see, I'm moving all the way to the right. I'm going to type times stats, another NCR, see that? And I'm going to go all the way to the right and say divided by another NCR. And now I'm going to go ahead and plug in. The first one is 3 and 3, right? Let me move this here so you can see. See, the first one is 3 and 3. That's what I plugged in, 3 and 3. The next one is 7 and 1, right? And what's on the bottom? What do I have on the bottom? 10C4. So I'm going to go ahead and plug in 10 to plug it here. 10 and 4. And now this is decimal. I'm going to go ahead, oops, not that. I'm going to go ahead and change that to a fraction. 1 over 30 is your final answer. So your probability is simply 1 over 30. Let me pull this down. Da 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 da. 1 over 30. Fair enough? All right, so I think this is exactly what you will be plugging into here. All right, let's go ahead and take a look at the next problem. A manager at a store is holding a contest where the first, 9th, and 19th customers of the day will win a prize. 100 people visit the store. So let me go ahead and draw a store for you. Don't be surprised with my drawing skills. Okay, so there are 100 people who visit the store. So this is the first guy, this is the second, this is the third, this is the fourth. So you get the idea. There are 100 people visiting the store. But only the first, the 9th, and the 19th will win a prize. Very good. 3 different friends visit the store that day. What is the probability that they are the first, 9th, and 19th? Let's see what's happening. What's the probability, they said. So let me take my beautiful drawing. Let me minimize it and move it here. Okay. So the first step is to find the probability. So I'm going to see, they're asking me the probability where the 3 friends will be the first, 9th, and the 19th. I'm going to start with how many ways those 100 people can come into the store. So how many ways can 100 people come into the store? Simply 100 factorial ways, right? 100 factorial, because any of the first 100 people can be the first one, second one, third one. Now if I take out the first, the 9th, and the 19th, what am I left with? I'm only left with 97 people. And out of those 97, how many ways can that be? 97 factorial. As simple as that. So the denominator is how many ways can 100 people come into the store? 100 ways, 100 factorial ways. So if I take out the 3 friends who will win the prize, how many people I have left? I have 97. How many ways can these 97 people come into the store? 97 factorial ways. So it's simply 97 over 100. Now if I put my handy dandy class calc, just give me 1 second here. What I'm going to do is I'm going to reduce this one. I don't need to see all of this. Okay. I'm going to go ahead, plug it here, delete this one. Oh, yeah, this one. So I am doing 97 factorial divided by 100 factorial. That looks like a big number, so we'll just leave it at that. So if you have to solve it, it is going to be 97 factorial is, so 97 factorial over 100 times 99 times 98 times 97 factorial. So as you can see, all right, that could be confusing. Let me go ahead and redo it. Let me delete this one here. I'm going to simplify this for you. So this is 97 factorial. And 100 factorial, I can write 100 factorial as 100 times 99 times 98 times 97 factorial. So 97 factorial cancel each other. So 1 over, let me go ahead and do that now. So 100 times 99 times 98. So that is 970,200. That's your probability. All right. And always, please, please, please keep in mind what's happening in the problem and what they're asking you. Let's take a look at the next one. Yeah, can you see this? Yeah. A flush in poker is having all same suite of cards in your poker hand. Remember that a standard deck of cards has 52 cards of four suites of club, diamonds, heart, and spade. Each suite has 13 cards in it. So we have a diamond, a heart. Can you see this? A diamond, a heart. Where is it? A club, and where's my spade? And a spade. Right? So 13 of each, 13 of this, 13 of this, 13 of this, and 13 of this. Okay? So what is the probability that a player is dealt 5 cards resulting in a flush that is not a suite of heart or club? So I cannot have a heart or I cannot have a club. So these two cannot be. So what are my options? Only two. Let's go ahead and take a look. What is the probability that a player is dealt 5 cards, resulting in a flush that is not a suite or not a suite of heart or a club? Again, when they ask us for probability, you always start with how many possible ways, total number of combinations here. So how many cards am I dealing with? Da, 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 da. 5 cards. So from 52, how can I pick 5? 52, it's a combination of 5. Fair enough. That's my denominator. Now, what are they saying? From the 5, what is the probability that, so I have to pick 5 from, remember, I cannot have a heart or a club. Heart and club are a no-no. These two are no-no. I only should have from a diamond and a spade, right? Okay, so what are they saying here? What is the probability that dealing 5 cards result in a flush that is not a heart or a club? Okay, so now take a look. I can have 5 of these, or I can have 5 of these. How many spades do I have? 13. How many di diamonds do I have? 13. So I can get 5 cards from either diamond or a spade, right? So I can get 5 cards have to be of the same suite. So that's one. But remember, I can either pick this or this. So I have two options, 2C1 right here. So what does that stand for? I can either choose, so the first one is you can either choose your spade or your diamond. How many ways can you choose that? From 2, you're choosing 1. So that is your 2C1. Once you choose that, how many do you have? Either this or this. You have 13 of this. So 13C5. All right? All right, let's go ahead and take a look at the next one. Again, please be very careful. This might get slightly confusing as you do combinations and permutations, but patience is the most important. Again, if you have any questions, you can always reach out to me or comment in this video below so I can respond to you. So quick recap. Remember what they said? We're dealing with 5 cards. How many ways can you pick 5? 52C5, right? But I have to pick 5 of the same. So I either choose my spade or my diamond. How many ways? From 2, I'm choosing 1. So that is 2C1. Once I choose that, I have to pick 5 from 13. So 13C5. All right. In a car race with 12 cars, it's a race. So tell me if it's a permutation or combination. It's a race. So does it matter who comes first, who comes second? Yes, it does. You make a bet predicting the ranking of top 3 cars. There you go. How many ways can 12 cars finish first, second, and third? So look what's happening here. You're racing 12 cars. There are 12 cars. You know it's a permutations. And you want first, second, and third. Fair enough. First, second, and third. So you want to pick 3 positions from 12 cars. So 12P3. All right. Okay, so the next one is You will just determine the method. You will just determine the method of the probability. That means you will go ahead and tell me if it is a permutation or if it's a combination. Okay? Again, permutation is where the arrangement matters, like in this case. Oops. Permutation is where the arrangement matters, like in this case. Do you see this arrangement? Combinations is just like dumping everything in your salad bowl. That's combination. I think I'm touching my screen too much, so ew. Trust me, those leaves are really dirty. Okay, now I have my glove. Now it should work perfect. So let's go ahead and take a look at the first problem here. Every US citizen is assigned a social security number. As soon as I say social security, now tell me, does your social security differ from mine? Yes, it has the same numbers, but it has pretty much the same amount of numbers. But does the order differ? Yes. So, okay. So you automatically know if it's a permutation or a combination, because if my number is 1, 2, 3, 4, 5, 6, 7, 8, 9, and your number is 2, 3, 4, 5, 6, 7, 8, 9, 1, then your number is different from my number, because the arrangement of your number is different from the arrangement of my number. When the arrangement on the order matters, it is a permutation. So this is a 10-digit number, right? Unique to each citizen. So the arrangement matters. The first three digits of the number are used to identify the area in which your number was first assigned. I didn't know that. Okay. Now what are they asking us? Let's minimize this a little bit. Okay. Let's see what they're asking us. First, we will decide if it's, no, I skipped a step. If there are 10 possible digits, how many different area numbers can there be? So they're asking us if there are 10 digits. Remember, only the first three digits tell me the area number. But before I do that, I have to decide if this is a permutation or a combination. Right away, I know it's a permutation because it is a social security number. Your number is different from my number. So I know there is that it's a permutation. So let's see. Da, 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 da. This is a permutation. We are listing all the possibilities, and order does matter. So the order does matter. So it is a permutation. What else? To solve the problem, we will group certain digits, so the order does not matter. No. To solve the problem, we want to list the digit to indicate specific areas, so the order does matter. So here they're asking us to pick everything that applies. So if you pick permutation, the order does matter. So I know this is a permutation because the order does matter. And I know to solve the problem, we want to list the digits to indicate specific areas, so the order will make a difference. Now that we know it's a permutation, let's go ahead and calculate the number of ways that the three digits can be arranged from the possible digits. Again, how many do I have? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So totally I have 10 digits. I'm going to write them big here. 10 digits. I know it's a permutation. I'm only picking three, the first three. 10p3. There you go. Let's go ahead and bring up the class calc. Where is my class calc? There you go. I'm gonna move it right here. So uh, stats, NP. So my N is 10 and my P is 3. So 720 possible areas, 720. Fair enough. 720. So NP3, because all they're asking me is they said, first tell me if it's a permutation or combination. Once you know it's a permutation or combination, go ahead and calculate how many number of ways the three digits can be arranged in the first 10 digits. So there you go. All right. So let me close class calc and let me go ahead and move on to the next one. All right, so here we have a smoothie shop. A smoothie shop offers its customers 11 different fruits and vegetables to add in their smoothie. So I'm adding, so this is what's happening in a smoothie shop. You turn your blender on and you put your first vegetable, second vegetable, third vegetable, and psh, you blend it all. Now tell me, does the order matter? It does not, because everything is getting mixed up in the smoothie anyway, right? So by default, I know it's a combination. All right, let's go ahead and read further. The shop's best-selling smoothies include four fruits and vegetables of a customer's choice. How many different smoothies can be made by customer choosing four fruits and vegetables from it? So first we have to decide if it's a permutation or a combination. It's a smoothie. I'm putting everything in and blending it. So it doesn't matter what goes first or what goes second. So I know it's a combination, right? This is a combination. We are grouping possibilities and the order does. Hold on a second. This has to say this is a combination problem and it should say the order does not matter. The order does not matter. The next one, how do I solve this? To solve this problem, we will group certain fruits and vegetables so the order will not matter. So there you go. So every time the order does not matter, it's a combination. Now, once I know this, what am I doing? I am choosing four fruits and vegetables from 11 different fruits and vegetables. How do I do that? Bring my handy dandy class calc, delete it, stats, NCR. From 11 vegetables, I am choosing four. So 330 ways. Fair enough? All right. Let's take a look at the next one. Patients in a clinical trial are taking 9 medications. Doctor wants to test to see whether administering two specific medications before the other drug affects patient's symptoms. Be very careful. You are the doctor here. You want to see if when I give these two drugs before the other drugs, does that make any difference? Now, let's say we take Tylenol and Motrin. Let's just say, I randomly pick those two. So, so you want to see, does it make any difference if I give Tylenol first or Motrin first? Or does it make any difference if I give Motrin first or Tylenol first? So you are trying to see if it makes a difference. So take a step back and see, does the order matter? Which medication goes first? Yes, it does. So when the order matters, it's a permutation. All right. So now that I know, let's go ahead and read the problem. How many ways can the doctor give patients two medications before the other drugs? Okay. But first we have to decide if it's a permutation or a combination. So I know it's a permutation. This is a permutation because we are listing possibilities and the order does matter. And to solve the problem, we will group certain medications. Um, to solve the problem, we will group certain medications so the order will not matter. No. To solve the problem, we want to list the medications so the order will matter. So when you're choosing permutation, order does matter. When you're choosing combinations, the order does not matter. Now that I know it's permutation, I am choosing two medications from 9 medications. As simple as that. Let me move this up. I'm choosing two medications from 9. I'm simply going to go to my class calc, delete this, stats, NPR, 9. I'm choosing 2 from 9, so 72 different ways. So this is 72. Fair enough? And again, please keep in mind permutation where the order matters, combination where the order does not. So when you're reading these problems, you have to be very careful and have a lot of patience. And again, if you have any questions or concerns, please let me know. And you can reach me through email or Teams, or you can just comment on the video below. Good luck.